Okay, let's continue. The atomic structure, according to this, we have a periodic table of the elements is arranged in order according to the atomic number of all the elements. Then, for example, atoms that are in the neutral state have an atomic number equal to the number of protons or number of electrons. As you can see, for example, ang isang atom is meron siyang neutral state na meron siyang atomic number. Then this atomic number also equal to the number of protons or number of electrons. Okay. Okay, next for atomic structure in a neutral state, it means no charge. The same number of electrons or negative charge cancel the same number of protons or positive charge. Okay, pag sinabi nating neutral state is kinakancel niya yung number ng electrons or negative charges, then with the same number of protons or positive charge. Okay, that is the neutral state. It means no charge. Same lang yung equal ng number at electrons at saka yung electrons or negative charge and cancel the same number of protons and positive charges. Okay, next. How about the electrons and energy levels? As you can see, we have the electrons orbit at a certain distance from the nucleus. As you can see, we have the electrons orbiting far from the nucleus have more energy than those near the nucleus. As you can see, for example, we have a discrete distance or orbit from the nucleus has its own certain energy level. Okay, later we'll have a figure about this orbit and the shells. Okay, now how about the electrons and energy levels? The orbits are grouped into energy bands or energy level known as shell. Okay, ang yung mga orbit, for example, nasa shell 1 siya, nakagroup siya sa shell 1, shell 2, shell 3, nakagroup into energy band or energy level na tinatawag nating shells. Each shell has a definite maximum number of electron at a permissible energy level. Then itong mga shell natin is meron siyang number ng electrons at a permissible energy level. Then the shell are designated as shell 1, shell 2, shell 3, and so on, with one being closest to the nucleus. Okay? Okay, naulit lang yung slides. Okay, next. As you can see, we have the, as I said before, ito na nga yung maximum number of electron in every shell. Pinapakita kung ilan yung electrons kada shell. For example, in the first shell, that will be 2 electron. And second shell will be 8 electron. And third shell is equal to 18 electron. That is near the nucleus in the center. Okay, ito yung ginamit ng formula para ma-compute yan. Ayan, yung number of electrons, that is 2n squared. The maximum number of electron, any, that can exist in each shell of an atom, as shown in the figure 1.2, can be calculated using this formula. Okay? Yung any is the maximum number of electron in a shell, then n is the number of the shell. Okay, then ito lang yung pinakita na yung solution kung paano na-compute ng number of electrons. The maximum number of electrons that can exist in the innermost shell or shell 1 is equivalent to 2 times 1 squared or equal to 2. Okay? Next, pinakita lang yung mga solution kung paano nakuha mo kapag nag-exist in shell 2. Ano yung maximum number ng electron? That will be, substitute lang natin yung 2 sa n equals to 2. That is 2 times 2 squared. That will be 2 times 4 equals to 8. Then the maximum number of electron that can exist in shell 3 naman is substitute lang natin yung 3. That will be 3 squared or 2 times 9 equal to 18. Then the maximum number of electron that can exist in a shell 4, substitute lang natin yung 4. That will be 4 squared times 2 or 2 times 16 equals to 32. Okay, yan lang yung formula ng number of electrons. Okay, next. Okay, how about the valence electrons? Ano yung valence electrons? These are the force of attraction between the positively charged nucleus and the negatively charged electron increases with the decreasing distance from the nucleus. Then there are higher energy and less tightly bound electrons on the outermost shell orbiting farther from the nucleus than those electrons closer to the nucleus. Okay, that is the valence electrons, that is the force of attraction between the positively charged nucleus and the negatively charged electron, increases with the decreasing distance from the nucleus. Okay, next. Okay, we have the outermost shell is known as the valence shell. Madali lang naman siyang tandaan. Pag sinabi nating outermost shell, that is the valence shell. Then kapag electrons on the outermost shell is tinatawag nating valence electrons. Okay? A valence electrons can break free from its atom. It's gain a sufficient energy from an external source. This is how conduction of materials work. Okay, paano ba nagkakameron ng conduction or nagiging conductor ang isang materials? Is nangyayari siya kapag ang valence electron can break free from its atom, then when it's gain sufficient energy also from an external source. Okay? Dito nangyayari yung conduction of a material. Pag sinabi natin conduction or conductor, it allows the flow of current through the materials. Okay? That is conduction. Okay, how about ionization? Ionization is a valence electrons that acquire a sufficient amount of energy called ionization energy. Ionization energy from an external source can easily jump to a higher energy shell. Okay, pag sinabi nating ionization is yung nagkakameron ng additional na energies or yung valence electrons is nagkakameron siya ng sufficient amount of energy. Okay, since nagkameron siya ng sufficient amount of energy, then it can easily jump to a higher energy shell. Then ang effect nito is magkakameron ng additional na valence electrons or excess. Then a neutral atom will have a excess positively charged when a valence electron escape. Okay, as I said before, since nag-easily jump yung ating valence electrons to a higher energy shell, then ang mangyayari sa neutral atom will have a excess positively charged when a valence electron escapes. Okay? Continuation of the ionization, as I said before, nagkakameron ng addition ng electron from. Pero ang isa pang definition ng ionization is nagkakameron din ng removal. Okay, these are the definition of ionization. The process of removal or addition of an electron from or to a neutral atom is known as ionization. Ibig sabihin, pwede siyang magkameron ng process ng removal ng electron from or to a neutral atom, or pwede rin naman magka-addition of an electron from or to neutral atom is also known as ionization. Okay? Next. A neutral atom that become a positively charged is also called a positive ion or cation. Okay, para doon sa mga ECE, o sa magbo-board, madali lang naman tandaan pag sinabi natin yung neutral atom is naging positively charged, is magiging positive ion or cation. Okay? Then the escape valence electron is called the free electron. From the word itself, naging free tawag na sa kanya since naging escape valence electron siya, ito is naging free electron na to. Okay, ang tawag. Okay, next. There's also a reverse process wherein the free electron that escape from the other atom collides with another atom. Okay, meron naman tayong tinatawag na condition na nagkakameron ng reverse process kapag yung free electron that escape from the other atom collides with another atom. Nagkameron ng pagbangga or collisions. Or nag-collide sila, yung free electrons that escape from other atom collides with another atom. Okay, then the captured free electron will be an extra to another atom resulting to an excess of an electron. Since yung captured na free electron is magiging extra siya dun sa another atom, then this will be result to an excess of an electron. Okay? A neutral atom that become a negatively charged atom is called a negative ion. Okay, ito yung counterpart ng positive ion. Kapag ang neutral atom is naging negatively charged atom, is tinatawag na siyang negative ion or anion. Okay, that is anion. Okay, now we go for explanation of inductor, insulator, conductor, and semiconductor. Okay, ano ba yung mga insulator, conductor, and semiconductor? Okay, all materials are made of an atom which contribute to electrical properties of a materials, including its ability to conduct electrical current. Okay, alam naman natin lahat ng mga materials is made of atom, then this will contribute to electrical properties ng materials, including its ability to conduct electrical current. Pag nagka-conduct siya ng electrical current is yung condition na to is tinatawag nating conductor. It allows the flow of current through the materials. An atom can be represented by the valence shell and a core that consists of all the inner shells and the nucleus. Carbon is used in some types of electrical resistor. Okay, ito na yung pinaka-example ng carbon or yung electronics or electrical resistor or electronics component. Yan, pinagagamitan ng carbon. As shown in the figure 1.3, we have a carbon atom as a 4 electrons in the valence shell and 2 electrons in the inner shell. Then the nucleus consists of a 6 proton and 6 neutron, so that positive 6 indicates the positively charged of the 6 protons. Then the core has a net charge of a positive 4, and this will be equal to positive 6 for nucleus and negative 2 for 2 inner shell electrons. Pinag-combine lang natin yung 6 at negative 2. That's why ang core ng carbon will have a net charge of positive 4. Okay? These are the conductor, semiconductor, insulator of different atomic structure shown in this figure 1.4. Okay, these are the 1.4. As you can see, we start with the conductor. Constant yung value niya, that is 1, 2, 3 valence electrons. Then, kapag semiconductor, that is equals to 4 valence electrons. And sa insulator naman is yung full valence shell, that is equal also to 5 hanggang 8 na valence shell or valence electrons. Okay? Okay, now we define insulator. An insulator is a material that does not conduct electrical current or has a poor conduction under a normal condition. Then the valence electrons are tightly bound to the atoms. Therefore, there are very few free electrons in an insulator. Okay, sa insulator, kasi ito yung material na hindi siya nagko-conduct ng electrical current or that does not conduct electrical current or has a poor conduction under a normal condition. Since meron siyang condition na to is ginagamit natin usually ito para sa mga safety purposes sa mga electric or sa mga kuryente para hindi ka basta-basta makuryente. Then valence electrons are tightly bound into the atoms. Since tightly bound yung kanyang valence electrons, there are very few electrons in an insulator. Since kakaunti yung free electrons, it will have a poor conduction under a normal condition and does not conduct electrical current. Okay, next. Okay, how about insulator also? Most good insulator are compounds rather than single element materials and have a very high resistivity. Okay, ito yung characteristic niya. Kaya usually ginagamit natin siya for safety purposes. Then example ng insulator is yung mga rubber, plastic, glass, mica, and quartz. Okay? Next. Okay, now we will explain the conductor. Conductor is a material that easily conducts electrical current. Most metals are good conductor. Pag sinabi natin conductor, it is can easily conduct electrical current and allows the flow of current through the materials. Then ito yung mga characteristic niya. Conductor are characterized by atoms with only one valence electrons. Then it will have very loosely bound to the atom. Okay, since ang kanyang characteristic ng atom is have only one valence electrons, then ang mangyayari is very loosely bound to the atom itong valence electrons. Okay? That's why it will have a characteristic as a good conductor or easily conducts electrical current. Okay, next. This loosely bound valence electron become free electrons, then therefore in a conductive materials, the free electrons are the valence electrons. Okay, dun sa mga conductive materials, katulad ng mga conductors, yung mga free electrons na to are valence electrons also. Because they are loosely bound valence electrons become free electrons. Ito na may example ng mga conductors, that is a single element material such as copper, silver, gold, and aluminum. Okay, that is the example of conductors. Okay, next we have the semiconductors. Okay, ano naman yung mga semiconductors? Semiconductors is a materials that is between conductors and insulator in its ability to conduct electrical current. Okay, ang ability kasi ng semicon is nasa pagitan siya or is between conductor at insulator. Since conductor din siya or meron din siyang ability lang is it can has a ability to conduct electrical current. Then a semiconductor is in its pure intrinsic state is neither a good conductor nor a good insulator. Okay, pag pure intrinsic kasi yung semicon, hindi siya good conductor, hindi rin siya a good insulator. Okay? Then a single element semiconductor are characterized by atoms with 4 valence electrons. Okay, constant na yung value niya ng semicon kapag characteristic niyang atom niya is with 4 valence electrons. The example of a semiconductor na materials that is a single element semiconductors are antimony, arsenic, astatine, boron, polonium, tellurium, silicon, and germanium. Okay. Next, compound semiconductors such as gallium arsenide and indium phosphide. Then we have also a gallium nitride. Then we have a silicon carbide and silicon germanium are also commonly used. Silicon is the most commonly used as a semiconductor. Okay. Comparison of a band gap. Okay, dito sa band gap is malalaman natin kung ang isang materials is semiconductor ba siya or conductor or insulator through this comparison of a band gap. When a valence electron breaks free from its atom when it's given sufficient energy, it can leave its valence shell. It will become a free electron and exist in conduction band. Then the difference in energy between the valence band and the conduction band is called an energy gap or band gap. Okay, yan yung explanation ng energy gap or band gap. The difference in energy between the valence band and the conduction band. Okay, another explanation for band gap. The band gap is the amount of energy that a valence electrons must have in order to jump from the valence band to the conduction band. Okay, ito rin yung amount ng energy na kailangan ng valence electrons in order to jump from valence band papunta dun sa conduction band. Okay, yan yung band gap. Once in the conduction band, the electron is free to move and free to attach to other atom throughout the materials. Okay, kaya dito na nagkakamera ng conduction ng isang materials. Kasi yung electron is free to move and free to attach to other atom throughout the materials. After nito na mag-jump from valence band papunta sa conduction band. Okay, through the band gap or the amount of energy that valence electrons must have. Okay, next. Okay, ito na yung mga type ng mga energy gap or band gap. Katulad sa insulator, meron tayong wide na band gap sa pagitan ng valence band at saka conduction band. Okay, ito yung band gap. Then kapag sa semiconductor materials naman, is narrow yung kanyang band gap sa pagitan ng valence band at saka conduction band. Okay, as you can see also here, sa conductor is there's no band gap. Okay, explain na natin. The energy gap or a band gap is in a region in insulator and semiconductor where no electrons exist. Then even though an electron may not exist in this region, an electron under certain condition can jump across it. Okay, for example, ito nga yung mga band gap ng conductor, semiconductor, and insulator. So figure 1.5. Okay, later we'll have a more explanation for this. Okay, ito na nga yung comparison ng band gap continuation. The difference in energy between the valence band and the conduction band is called energy gap. Okay, naulit lang yung slides already discussed. Okay, discuss na natin yung mga band gap sa mga sa conductor. The conduction band and the valence band overlaps since there's no band gap. Sa conductor kasi, okay, ito yung conductors, there's no band gap. Kaya anong nangyayari is, the conduction band and the valence band overlap. Since there's no band gap, then ang electrons in the valence band move freely into the conduction band. So there are always electrons available as a free electrons. Since there's no band gap, is yung electrons sa valence band, dito is madali siya makakapunta sa conduction band, or yung electron na to is can move in the valence band, can move freely into the conduction band, so there are always electrons available as a free electrons. Kaya nagkakameron ng conduction. Then sa insulator naman, the conduction band and the valence band are farther away, then the band gap is very wide. Okay, sa insulator. Okay, makikita natin sa insulator is since wide yung band gap sa pagitan ng valence band and conduction band, ang nangyayari is, ang effect nito is, electrons are steady and remain as a valence electrons in the valence band, and it cannot jump across the conduction band. Then the band gap can be crossed only when there are condition of a breakdown condition. Okay, since there's no since the band gap for insulator is very wide, ang nangyayari nun is ang electron are steady and remain as a valence electrons in the valence band. Kasi nga masyadong malayo. Kaya naka-steady lang yung electrons and remain as a valence electrons in the valence band. Then meron lang since wide yung band gap, it cannot jump across the conduction band. Pero meron tayong condition na tinatawag na breakdown condition, wherein the band gap can be crossed only when breakdown condition occurs. Okay? Okay, how about sa semiconductors? Ano yung type ng band gap niya? Sa semiconductors, the conduction band and the valence band depends on a semiconductor materials. The band gap is smaller than insulator and bigger than conductor. Okay, ito yung characteristic niya. Kapag ang semiconductor is nasa characteristic ng insulator, the band gap is smaller than insulator. Then, ang characteristic ng semiconductor also is bigger than the conductor. Okay? Ang effect nito, check natin sa semiconductor, ang band gap niya. Okay, ang band gap sa semiconductor is hindi naman siya wide tsaka no band gap. Is narrow yung kanyang band gap. Meron pa rin konti. Sa pagitan ng valence band at conduction band, kaya nangyayari is the electrons are steady in the valence band but can easily jump into the conduction band if enough energy is absorbed. Okay, nangyayari is yung electrons natin is naka-steady lang siya in the valence band but can easily jump in the conduction band kung ang condition is meron siyang enough energy is absorbed. Okay, that's the characteristic of a semiconductor and the band gap on its materials. Okay, now we will explain the silicon. Silicon is used in diodes and transistor in integrated circuits and other semiconductor devices. Both silicon and germanium have 4 valence electrons. Okay, ano ba nangyayari? Kapag ang isang silicon is meron siyang 4 valence electrons. Okay, type din yung semiconductor kasi is type din naman siya ng silicon at saka germanium. Yung silicon at saka germanium is type din siya ng semiconductor. Doon din kaya constant din ang kanyang value na meron siyang 4 valence electrons. As shown in the figure 1.6 is the valence electrons in a silicon are in the third shell. Okay, yung sa silicon kasi is nasa third shell yung kanyang valence electrons. Pagdating naman sa germanium, ang valence electron nito is nasa fourth shell. Okay? That's why we have positive 14 for silicon, the atoms of silicon. Then for germanium, we have 32. Okay? Okay, next, the valence electrons in a silicon are closer to the nucleus than those in germanium. Then silicon is more stable than germanium as germanium has a higher energy level which only required a smaller amount of addition energy. Okay, yun ang disadvantage sa germanium is meron siyang higher energy level which only required also a smaller amount of additional energy. Then this property makes a germanium more unstable at higher temperature and result in an excessive reverse current. Then this why silicon is more widely used semiconductive materials. Okay?